Hello guys, we react to Matthew Berman video. I love this guy. O4 is here. It should be very interesting video.
AI just dropped two brand new models, O3 and O4 Mini. These are incredible cutting edge models, but the best part, and what seems to be maybe, in my opinion, a new scaling law, is that they have access to full tool usage. And we not only got O3 and O4 Mini, we got the one more thing surprise from OpenAI. And they dropped a brand new project which looks incredible. I'll tell you that towards the end. Here's the blog post introducing OpenAI O3 and O4 Mini. This is the first time we've seen an O4 model, but this is the full version of O3, and the performance is incredible against the benchmarks. According to OpenAI, these are the smartest models we've released to date, representing a step change in ChatGPT's capabilities for everyone, from curious users to advanced researchers. And one thing that they emphasized throughout the live stream, which I'll show you a couple clips from, and this blog post, is that they have agentic tool use capabilities. That is the key. The raw intelligence of these models certainly are getting better, but the fact that they can use these tools effectively is the key ingredient here. And if you remember back to the previous O family,
Which are these tools? The fact that it can use these tools. Which are these tools? OpenAI tools? Other tools?
of
Can we plug tools?
model releases, they did not have tool usage out of the gate. So not only do they have tool usage out of the gate, they're actually really good at it. And not only that, according to OpenAI, these are the first models that they've released that are capable of truly novel ideas. And coming up with novel ideas, you already know if you've watched my channel, that is the prerequisite for hitting the
AI takes control. It has ideas. Guys, be careful. The AI now have ideas about humanity future.
intelligence explosion. That's what's required for these models to do research and improve themselves iteratively, infinitely. And keep in mind, these models are multimodal. They can input different modalities, text, images, audio, and they can also output multimodality. Now, interestingly, and totally in line with OpenAI's naming, O3 is actually the best model, not O4 Mini. O4, I'm guessing, will be the best model, but for now we have O3 and then O4 Mini. And you know what? Enough talk. Before I get into the benchmarks, let me show you a demo from the live stream. And what's really,
Of course, following the pure logic. 03, 3 is better than 4.
impressive about this, and keep an eye on it, is that you're going to see iterative tool use. This is not just it's using one tool and then outputs the result. It is trying a bunch of different tools to accomplish the task. And if you watch it, it is very reminiscent of Manus. These truly are agentic models.
All right, we're going to show you some things that O3 can do. I'll start with a science example. So this will be a physics poster. So I'm going to let O3 start thinking now so it can take its time. What I'm going to feed it is a poster of some physics internship that I did in 2015, so 10 years ago. And this poster, or the project, was supposed to estimate a quantity called the proton isovector scalar charge. It's a beyond the standard model of particle physics quantity that tells you how short-range interactions, how strong they are. And what you'll see is that the model, O3, is zooming in. It's kind of like browsing around. Here, I'll zoom out just to get a little bit better view. And it is kind of looking for the right quantities for the question I asked it, which is to basically find this result that I had and compare it to recent literature. But there's a small twist. The result actually isn't in the poster, and that's because I didn't have it yet. Although it's in like the final paper for this project, it's not in this poster, and I'm actually asking O3 to do the rest of the project for me, essentially.
He uses the same trick at OpenAI.
Yeah. It's true. Great. So it found the plot that I wanted it to find. It's supposed to figure out that it needs to like find the slope of this plot, extrapolate down to a specific like physical quark mass, and then like grab that quantity, and then actually apply another quantity to normalize that value. And I think it has already kind of figured out that this is what it should do, but it is just spending a little bit more time exploring the image. Okay, it's good. It's now going to browse the web for recent results.
How long do you think it would take you to do this task?
Quite a long time. Yeah, so I mean, it took me a long time just to remember what my poster even meant in the first place. And I also didn't even realize that the result wasn't there when I first asked it this question. It actually told me that, which was nice. So many days just for me to even like onboard myself back to my project, and then a few days more probably to actually like search through the literature. And I mean, it must have just read at least like 10 different papers in a few seconds for me. So that's a huge time savings. Great, so it has summarized my result here, and these numbers look correct to me. So it's figured out like there's like this unnormalized value that it's like estimated by extrapolating, and that when you multiply by this specific constant, that it will renormalize it. And it says, okay, you would have ended up with this, which is somewhat close. I think it ended up around like 1.2 in my paper. And then it compares with the actual literature here. So there's a few different estimates, and looks a little close, I'd say. So let's see what it says. It says my bear value looks high because it needs to be renormalized. That's correct. After you multiply by that, you get something that's more consistent with the state-of-the-art results. That's great. But it says my precision isn't as good as the state-of-the-art, which is fine. It was an internship.
Not bad for an internship.
Exactly. So
We'll allow it.
I'll take it. I'll take it. So it seems like it's still a reasonable estimate that maybe has a little bit more uncertainty than recent results, which is great. So the field has made progress, which is awesome to see.
How cool is that? These are complex tasks that O3 is given. And in the live stream, Greg
Did you even understood what the thing is? I think that example was inappropriate for the testing, for the live presentation. I don't see it appropriate. I don't know why.
Brockman says, this is still just next token prediction. So they really do believe we have not hit a wall yet. And they specifically call out they are doing two types of scaling, still the pre-training and then also the post-training with reinforcement learning. And in my opinion, the ability to use tools is really another scaling law altogether. All right, let me show you some of the benchmarks now. We have O3 and O4 Mini, and these are the hardest benchmarks in the world. So we have AIME 2024 competition math. Here's O1 at 74%, O3 Mini at 87%, O3 with no tools at 91%, and then O4 Mini with no tools at 93%. Now, O4 Mini is supposed to be the faster, cheaper alternative to O3. So you have a lot of options at this point, and yes, it's very confusing. And I actually have a theory as to how these models are coming to be, and I'll share that in a moment. So we have the AIME 2025 math, 79% for O1, 86% for O3 Mini, 88% for O3 with no tools, and 92% for O4 Mini with no tools. And keep in mind, they are specifically calling out no tools because when you give them tools, they perform so much better. Here's Code Forces. Look at this. O3 with the terminal, 2700. And O4 Mini with terminal, 2700 as well. That puts these two models in the top 200 ranking of coders in this code competition in the entire world. Top 200. We have GPQA Diamond, which is PhD level science questions. A nice bump from O1 and O3 Mini. I wouldn't say a crazy bump, but certainly a very nice bump. Humanities last exam over here, this is a substantial bump. We have O3 Mini at 13%. We have O3 with no tools at 20%. And then we have O3 with Python plus browsing tools at 25%. O4 Mini no tools, 14%. O4 Mini with Python and browsing tools, 17%. And then, of course, deep research still number one. And what is the difference between deep research and these other models? Well, I think it's just additional agentic scaffolding and more tool usage. So I really want to emphasize how excited I am about tool usage and agentic scaffolding. This is something I've been talking about for a long time. So if you've watched any of my videos, you know I am bullish on agents. Here's some multimodal benchmarks. We have MMMU, college level visual problem solving. O3 coming in 5 points higher than O1, and O4 Mini coming in.
I don't understand why this benchmarking become vendor specific now. Why? GPT compared to their models, compared to the competition, open source models, the Google models. I don't.
4 points higher. We have Math Vista, 87% for O3, 84% for O4 Mini. We have Charchive Reasoning, 75% for O3, which is a huge jump from the 55% at O1, and then 72 for O4 Mini. Here we have the SWE Lancer, and remember, the SWE Lancer is a benchmark in which these models are tasked with going and actually accomplishing real-world software engineering tasks and earning money from them. So we have O1 High earning $28,500, O3 Mini High $17,000, O3 High $65,000, and O4 Mini High $56,000. There is an arbitrage opportunity happening right in front of our eyes. We have SWE Bench Verified, O1 48%, O3 Mini 49%, O3 69%, and O4 Mini 68%. So very nice jumps on SWE Bench. And as you can tell, these models are much better at coding, which is going to be very important when I show you one more thing that OpenAI shared. Here's the Aider polyglot test for code editing accuracy. Whole and diff, O3 High, whole and diff, significantly higher than O3 Mini High, and even higher than O4 Mini High. We have instruction following and agentic tool use. O3 is doing much better than the other models. Okay, let me share my theory as to where these models are coming from. So one thing I've talked about on this channel is how these thinking models come to be. They take a really good base model and they apply reinforcement learning with verifiable rewards to elicit the thinking behavior. And so what is the base model for these models? Well, if you remember, Sam Altman just a few weeks ago said they actually figured out that they can make GPT-5 much better than they thought originally. And so what I think is happening is they are taking different checkpoints of GPT-5 and then using those as the base model for these thinking models and applying reinforcement learning to them. And they're continuing to train GPT.
Look at this. Look at this. Versioning GPT-5, O4-mini, O3. What? So what O3 and O4-mini are checkpoints of GPT-5? Yeah, it might happen, but guys, please, why it should be complicated?
These thinking models.
It can be easy.
And applying reinforcement learning to them. And they're continuing to train GPT-5. And then every time they take a pause, look at the checkpoint, and run benchmarks against it.
Maybe we need a new versioning concept for LLM. Because the minor patch versioning concept was working for manually written code. Maybe the world needs another versioning strategy for like maybe we need different versions for the training part, for the thinking part, for the input output part, for the validation, security part, like prevention of bad prompts, and don't tell this guy how to make a bomb. So maybe we need 4 different versions. Maybe we need 5 different versions. And then on each like new model, we'll have a bump on on the versions which suffer a change, because now we don't know, the whole thing is changed. Now what is different between O3 and O1? Who knows? Maybe we need some more verbose versioning system, because I don't see the logic. O4,
They are just surprised that they continue to do better and better. The scaling laws are unfettered. So that's what I think is happening. They have GPT-5 and they continue to train it and let it bake, and they're using different checkpoints as the model progresses for the O3, O3 mini, O4, O4 mini models. All right, next, a big emphasis for OpenAI, especially this week, seems to be cost. The GPT 4.1 model was much cheaper and much faster than GPT 4o and other similar models. And now what we're seeing with O3 and O4 mini is they are also cheaper, more efficient, and faster. Check this out. So this is the estimated inference cost on the x-axis and the AMI 2025 with no tools on the y-axis. As you can see, the O4 mini model is much better across the board and only slightly more expensive than its comparable last generation model. However, look at this. The GPQA pass at 1, no tools, estimated inference cost. We can see once again, much better performance for similar or even less cost. So they are really doubling down on being very cost efficient, and that is a really smart play, because as enterprises, as developers decide which AI models to build their tools on, they're going to look at cost as a significant signal on which model to choose.
I think the developers might decide which, it's like an interface. If they need the model for complex task, if they need a model for deeper understanding, for breaking down complexity, for analyzing, these are all responsibilities, and it's like an interface. The application needs something which implements thinking. I call it responsibility, but it's like an interface. And then there would be a for the application there would be a test cases and different models, and then the developer, or at least a stable agnostic LLM model agnostic application can do the following. It just run the tests on different models, presumably having the assumed capabilities like thinking, deep reasoning, or breaking down, or providing structured output is another capability. And yeah, based on the testing and of course cost, there can be a conclusion, and there would be a conclusion: is it usable? I think this kind of matrix would be part of the future, like every application to have a matrix of tests for certain tasks. And for example, there would be because all these things change every day, and all these models are appearing and disappearing and changing, and I imagine kind of an infinite pipeline which is running these tests daily with new LLM models, and finding an algorithm, finding, for example, which one is better. And better, for example, means cheaper, and at least I mean a certain reliability level, and cheaper. If it's cheaper, so yeah. But let's not go so deep, imagining stuff.
But there is a problem with depending on OpenAI. And again, I'll talk about that when I show you their one more thing towards the end of this video. Now let's look at the cost of performance comparison for O3 to O1. So we have the inference cost over here, and this is
That's interesting one. O1 low is kind of how much? 5 times cheaper than O3 low.
is O1 low, medium, and high. And then here's O3 low, which actually does not perform as well, very close, but not as well. But O3 medium, much better and much cheaper. And then O3 high, much better.
It doesn't perform very well O3 low. Okay, so it's twice.
Better, much cheaper. And same thing over here, GPQA, much better and much cheaper across the board. All right, so what is that one last thing? Well, they dropped Codex CLI. This is essentially agentic coding powered by OpenAI in your console, locally on your computer, obviously powered by cloud-based models, but still, this is an open source project that OpenAI is dropping, and it is a direct competitor to Claude Code. It is actually almost identical to Claude Code. Codex CLI can read files from your computer, it can write files to your computer, and so you get all of the benefits of multimodal reasoning, all of the tool usage, the thinking, but now you can give it your coding environment to work within and your code base as well. So very cool, very exciting. But now let me talk about the platform risk. So let's say you're a developer and you're deciding which models to use for your project. If you choose OpenAI, you run the risk of OpenAI building what you have built. So this is called platform risk. Now here's a perfect example. If you're building a vibe coding tool, all of a sudden, OpenAI is now creeping in your direction with Codex CLI. Now, this is certainly far from the mainstream vibe coding tools out there, and it is what they call a reference project. But I've heard all of this before, having been in Silicon Valley for many years. Companies that you build on top of, look at what their customers are building, and if there's a big enough margin and a big enough market, they will just build it. There's very little downside in them off 1 or 2 or even 5 developers to essentially build a new project in an entirely new market and open
Okay, this is a little bit.
up a new revenue stream. So be very careful, diversify away from any single model provider. That is also why I'm a big proponent of open source. And just like Claude Code, you can give Codex CLI full auto mode and allow it to essentially run wild, they say safely, and just execute commands on your computer, build out what you ask it to build. And of course, I'm gonna be trying it out. It looks really cool. They are also launching a $1 million initiative to support projects using Codex CLI and OpenAI models. We'll evaluate and accept applications for grants in increments of $25,000 in the form of API credits. Proposals can be submitted here. So if you build something cool, go ask them for some credits. All right, so who gets all of this? Plus Pro and Team users will see O3, O4 Mini, and O4 Mini High in the model selector starting today, replacing O1, O3 Mini, and O3.
That's a big market. Interacting with developers, it's a big market. But I don't get it. There is a desktop application in Mac which have integrations like I can use a PHP Storm with ChatGPT on Mac and achieve asking the ChatGPT native application, and it's updating and putting into context files which are opened in my IDE, PHP Storm. But it has a couple of bugs. I don't get it. Why they didn't just fix the bugs and the flaw? Why they move to a CLI, or they just introduce a new product, or what? I have course, COI is more controllable and it's more like predictable, and it's less complicated, and it's more coverage. You can use it on Linux, Windows, Mac. But I
3 Mini High. Enterprise and EDU users will gain access in 1 week, and free users can try O4 Mini by selecting Think in the Composer before submitting their query. Rate limits across all plans remain unchanged from the prior set of models. So I'm definitely going to be testing this out. I definitely want to see it versus Gemini 2.5 Pro, which is the gold standard of AI models and especially coding models out there right now. So check it out. Let me know what you think. Drop a comment below. I want to know what you think about platform risk and building on top of OpenAI. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.
Building with OpenAI risk. I mean, yeah. That was a topic from the start of the AI. Everybody got scared to give some data to the AI. Guys, our data, and either way, it's in, if it's not next to you, sitting on a PC here next to you, encrypted with a proprietary algorithm, without internet access, it's already in somebody else's possession. Like, why should we overthink? So I don't think we should overthink. Will our code goes to OpenAI or Google or whoever is there? I mean, what does it matter where it you go? It will go somewhere. If you use Google, it will go there. If you use Meta, it might go there. If you use OpenAI, it might go there. So I don't think it so much matters. I mean, if you have some gem data which doesn't need to be anywhere in anybody's possession on this world, there are ways, but they are not so straightforward. Very nice video. I need to see more comparisons between Gemini 2.5 and these OpenAI models. That would be interesting. Okay, guys, thank you. See you in the next one.